Okay, so you need a mat set to start with. There it is, all the parts, all the pieces ready to go. Okay, so bisecting an angle, we start with a straight line. I'm going to work with a 60-degree angle that I draw with my 60-30 set square. The only reason I'm doing that is because it's just easy to work with. You can do this for obviously for any angle you like. Slipped a bit there. Okay, so I'm going to make the lines as long as you like. It doesn't really matter how long your lines are, as long as you've got an angle there ready to work with. Okay, so I've actually used the pencil here, but the pencil will mark an arc on the two arms of any length you like. I've set my compass there to any length you like. The needle is at the vertex of the two lines, and I mark an arc there any length I like, and the only condition then is that my pencil slipped there, so just make sure you get a good solid arc, you know where it is. Don't change the length of your compass, and mark another two arcs. Okay, so there's another two arcs off the original two, so putting my needle at the intersection of my arcs and my arms is what I've done there, and I've marked two more arcs. Okay, I'm just filling that in with the pencil now to make it clear in the video where those arcs are that I've marked. And what we have now is, well, we're ready to bisect the angle. So the intersection of the two arcs and the intersection of the two lines, the vertex of that angle. If I draw a line between them, it bisects the angle. Now I said I started with 60, so I should have two 30-degree angles, and you can see from my 30-60 set square there that they're two 30-degree angles. You could measure this with a protractor as well, would do the same job. So two 30-degree angles, well, from what was originally a 60-degree angle, so that's the angle bisected. Now, if we look at the points, these 2 points here, you see the distance between those 2 points is the same as the distance between those two. Okay, they're both radii of the circle that we've drawn with our compass. This line that I'm drawing now, okay, that also has the same distance, and so does this line here, because we never changed the length of our compass. So each line that we drew, each arc that we drew, is the same distance from where the needle stood. So all four of these lines are the same length, which means we've got two common sides, two identical sides, one common side. We've got two congruent triangles with those two angles that I've just marked being corresponding angles and therefore equal. That's a characteristic of congruent triangles. So up next, finding the perpendicular bisector of a straight line. So this is a 10 centimeter line. We're going to split it in two with a line that is making 90 degrees. Okay, so here is my compass. Stick the needle at one end of the line. I can make the compass any length I like as long as it's more than halfway across the line. Okay, so I mark an arc down the bottom and an arc up the top. What some people will do is just draw one big arc the whole way through. You can see me doing it with the pencil there. Keep the compass the same length. Mark an arc on the other side. Again, just one big long arc is what I've gone for, and as long as you're more than halfway, your two circles or your two arcs will overlap each other. Okay, so I just mark it in with a pen now. Again, there's the arc down the bottom, so the intersection of those 2 points is the same distance from the two ends of my line segment there. Okay, but more importantly, what I'm going to do now is just take my straight edge and join the two intersections of my arcs together. And that line that I've drawn now is the perpendicular bisector of the line, the original line. Okay, so to check it, if it's perpendicular, I use the corner of my set square, 90 degrees, there we go. To check that it's 5 centimeters, I can use the ruler there. Okay, and I think you can see there that's 5 centimeters, which means we split our 10 centimeter line in half with a line that's at 90 degrees too. Okay, so just to talk you through what happened there, this line that I'm drawing now is just the length between my needle and my pencil and my compass. So is this line, so they're the same length, and so is this line here, and this line here. Okay, they're all the same length, or whatever length I set my compass to. So if you don't believe me, I'll just check it. That is, I think, 64 millimeters. So is that 64. This one is 64, and of course the last one is 64. Okay, so they're all the same length, so we'll just mark them as being the same length. And you might spot now that we have isosceles triangles, both of which are also congruent actually. Okay, they've got a common side, two common angles. So if I now draw the line that we call the perpendicular bisector, why can we call it perpendicular and a bisector? Well, if you look at that triangle there, it's another isosceles triangle. And you might spot that it's congruent with the triangle to the right. Okay, the reason being they have two common sides and a common angle there in between them. Okay, so being congruent triangles, I can now say that, well, this angle here on the isosceles triangle to the right is the same as the angle on the isosceles triangle to the left. So if you look at the small triangle on the top left, it's congruent with the triangle on the top right. Okay, we've got two common angles. We've got two sides that are the same length as well. Okay, so that means the corresponding angles are equal. This angle corresponds to this angle, so they're equal angles. They add up to give 180, so they must be two 90-degree angles. So that's why it's perpendicular bisector. And again, if you look, this side and this side are corresponding sides in the two triangles. So that means that they're equal. So that's why it's a bisector. And just as a last point in the diagram that I've drawn, the line that I'm marking there, those two sides are equal as well for completeness. Drawing a line perpendicular to another line, be it through a point on the line or just through some other random point that you need to draw perpendicular through. You're just going to use your set square here. So if you line your set square up, there we go. If you line it up so that the bottom of your set square lines up with your line, your set square has a 90-degree angle on it, so you can just mark the other line there, and that's going to be a perpendicular line that'll go through the point you want it to. You can finish it off then with any kind of a straight edge. And you've got your perpendicular there. Okay, through a point, exact same thing. I'll just flip this over. Work with your set square lined up along your line and against your point that you want to draw your perpendicular through, and putting your pen on the point there, you get your perpendicular line. Okay, so again, you can finish that off any way you need to. And you've got your 90-degree angle down the bottom there, and you can check that. The usual way we check 90-degree angles is with the set square, so you can check it there. There we go. Lovely. So suppose you've got a random point here and a line here, and you want to draw another line through the point that is parallel to your first line. So again, you're going to use your set square here and your ruler. You're going to line your set square up so that it's along the line that you want, that you're working with to start with, and then move your ruler in so that they meet just through the point you're interested in. Okay, your ruler is now perpendicular to the original line, so if you slide your set square up and draw a line along the base there carefully, okay, the line you've drawn there will be parallel. And if you then just carry it on through the point you're interested in, you've got two parallel lines now. You can mark them as such. And if you want to check this, maybe the best way is to just draw a transversal and check, yourselves that corresponding angles should be equal. So that's just a check on that. You can use your protractor. Okay, so dividing a line segment into three equal sections, we'll need your compass and your ruler. I'm going to start with this 9 centimeter line, so if I do this properly I shall get three 3 centimeter lines. This, by the way, is the 7th construction of 15 that you need to know, and I'm doing them in the order of the syllabus. So I'll start off by drawing a line at any angle I like to my original line. Okay, so there it is there, any angle I like just draw some. I like to go with a reasonably big angle, just tidies it up usually. Set your compass to any length you like and start marking arcs on your new line. Okay, so needle moves up to the arc you've just drawn, and then it moves up again to the arc you've just drawn, and you're marking a new arc. So the point of all this is that those three sections that I've divided my line into are all the same length. They're all just whatever length my compass was set to. Okay, I just need to extend that line a bit. I've got three equal sections there. So I now connect either arm of my two, and I have a triangle here. Okay, and this works on the principle of similar triangles. But anyway, I've got I'll just mark in these so that they're clear in the video. Okay, so you should be working with pencil, but I work with pen to keep the video clear. Okay, so there's my three equal line segments connected. Now if I draw a line parallel, I think I'm just going to get my other set square here, and I'm going to work with that. If I draw a line through my arcs, the intersection of my arcs and my line, that's parallel to that line that I'm just sitting on there. Okay, this parallel line here, if I draw that through there, and then I can't draw the other one just yet, I'll draw it in a second. So here's my first parallel line. I'm going to bring it all the way to the bottom. Okay, and now these two lines are parallel. And then draw a second parallel line, which again, line up my two set squares back to back, slide one of them along, and there we go. Oh, it's not quite. Hang on. May as well just get this right. Okay, there we go. That looks tidy. So there's my next parallel line, and I'll just complete it here. It's important to be careful when you work here. So I've got my three parallel lines, which means my three line segments at the bottom there should now all be equal. I can check that with the ruler. Like I said, it should be 3 centimeters, which it is, 3 centimeters here, which it is, and 3 centimeters here. Lovely. Okay, so 3, 3, and 3, and we've split it in 3 parts. So just to go through what's happening here, we've got theorem 12 for transversals on a triangle says that transversals, if they split the first side in a 1:1:1 ratio, parallel lines that is, if they split the first side in a 1:1 ratio, they'll split the second side in a 1:1:1 ratio as well. And the only way to do that is to split it in 3. So that's theorem 12, transversals on a triangle. I'll just point up here, we also have similar triangles. These three angles are corresponding angles on parallel lines. This is a common angle to all three triangles that we're about to look at. So if we look at those two angles, that third angle, we'll just call it double dot. There it is there. Well, this triangle here contains the same two base angles, so it must have the same top angle, double dot. You could also say that they're corresponding angles. And this triangle here has the same two base angles, it must contain the same top angle. So that angle, the triangle, that one, and this one, there are three similar triangles we have here as well. That was the 6th item on our list. The 7th item on our list is the exact same. This is a 10 centimeter line. We should be able to split this into any number of equal segments that they ask us to. So I'm going to split it into 5 segments. Draw my line as before, any angle, doesn't matter. Take my compass, I'm going to mark off 5 equal length segments on my new line. Okay, so there's 1, 2, 3, 4. I think I'm going to run out of space here. I am. Okay, I'm just going to make my compass smaller. Sorry about this. I'll mark off 5 smaller segments. There's 1, 2, 3, 4, 5. Okay, so as before, I'll just mark those in with pen and make them clear on the video. Okay, hopefully that's nice and clear for you now. As before, I go to my highest up one and I connect it to the end of my line. Okay, I take my 2 set squares and draw lines parallel to that side through each of my arcs that I've marked off there. Right, just have some careful to keep your set square in place. There's one slipped. Okay, so these are my parallel lines. I'll just tidy that up. Okay, so 5 segments, 5 parallel lines. Tidy them up now with my ruler. There we go. Okay, so these should be, well, it was a 10 centimeter line in 5 segments, should be 2 centimeter lines each. That's my last one up here. So I should, if I've done it right, have 5 equal segments down the bottom. There's 1, 2, 3, 4, 5. They should be 2 centimeters each. Where's my ruler? 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters, and 2 centimeters. Yeah. Okay, I think that one might be a little bit off, but you can see the idea. Okay, so 8 and 9 I'm just going to record together. They're pretty easy to do. 8 is drawing a line segment of a given length. So if there's your point A, you want to draw a 6 centimeter line. You do it with the ruler. Hopefully you know how to do that. 9 is drawing an angle of a given size. I'm going to pick 45 because we can check it with the set square, see if we get it right. So we use our protractor, line up the base with the line. Mark 45 there. You can see 40 halfway between is 45, and you can see the measure up the top. So 45 degrees. I'm also going to do 110 just to show you the obtuse scale. So from how I'm doing it, my obtuse scale is on the inside of the protractor. That's 110 degrees. Okay, so there's a 45 degree angle, and there is a 110 degree angle. And I'll just show you now the set square. That's 45 degrees, fits in perfectly. 45, 45 set square, and I'll just mark that. You're going to have to trust me on the 110 degree angle. Construction 10 says draw a triangle given the lengths of any 3 sides. So here I've picked a triangle with sides 5, 12 and 13. They're called a Pythagorean triple. I should get a right angle triangle if I do this properly. So I start off with my 13 centimeter line down the bottom. Okay, I always pick the biggest line to draw as the base. I just find it's the tidiest way to do it. So that's 13 centimeters. What I do next is I take my compass and I measure it up against my ruler. It's going to be tricky to get on camera here. I want my compass to be 12 centimeters apart. Okay, I want my needle to be at 0 here, and I want to stretch out my compass so that it's at 12 centimeters. Is that at 12? Bit fiddly. There we go. 12 centimeters. Okay, once I have that done, I'm going to stick the needle of my compass in at one end of the line and draw an arc at the far end. Okay, I'll draw that arc in pen in just a second. So that arc there is 12 centimeters from the point. Okay, so that arc and my point are 12 centimeters apart, which is one side of my triangle. The other side needs to be 5 centimeters away from the far end. So I adjust my compass to 5 centimeters. Okay, and if I'm happy with that, stick the needle in the far end and mark an arc again. Okay, so those two arcs intersect. So at the point of intersection, I'm sorry, I'll just draw them in pen here, get them nice and clear. There's my 12 centimeter arc. That's 12 centimeters from that point there. Every point on this arc is 5 centimeters from that point there. So what I get is this line, which is 5 centimeters from one end of my triangle, and this line, which is 12 centimeters from the other. Okay, as I said there, 5, 12, and 13 are what are called a Pythagorean triple. They're whole numbers that follow Pythagoras' rule. So if I've done it right, yeah, you can see there with my set square, I've got a 90-degree angle, which is great. Okay, I can mark that as 90 degrees. This side is 5, 5 squared is 25, this side is 12, 12 squared is 144, 25 and 144 give 169, and this side is 13, 13 squared also gives 169, so it follows Pythagoras. So construction 11 says you need to be able to draw a triangle given the side angle side data. So the example I picked is to draw a triangle with sides 6 centimeters and 5 centimeters and angle 25. So we'll start off as before with our biggest side, which is 6 centimeters. There's my 6 centimeter line there. Okay, once we're happy with that, we need to take our protractor and draw our angle of 25 degrees. So I line it up so that the cross of my protractor is just meeting the end of my line. Okay, just push that up. Yeah. Okay, so my line should run right along the 0 marked on my protractor. And I say that's 10 degrees, 20 degrees, there's 20, 30. So somewhere between there, the big line represents 5. That's 25 degrees there. So this is a 25-degree angle I have here. Lastly, I take my ruler and measure my 5 centimeter side. 5 centimeters. Oh, that's handy. It came out to be 5 centimeters perfectly there. Okay, so the last thing I do then is connect it all up. That's an interesting one. There we go. Okay, and then we can move on to construction 12, which is drawing a triangle given 2 angles on one side. But anyway, there's my triangle drawn. Construction 12 says construct a triangle given angle, side, angle, data. So my example is to draw the triangle XYZ with sides 6 centimeters and 2 angles of size 40 and 30. So I'll call this point X, call this point Y. I'm going to have Z up here somewhere in just a minute. I'm going to take my protractor. I'm going to measure out from X my 30-degree triangle, and that is going to be that line there. I'll measure out from Y my 40-degree triangle. So this is using the scale on the far side, so it goes from being on the inside here being on the outside over here. That's okay. 10, 20, 30, there's 40 degrees. Okay, and that's my triangle, so that point there is X. It doesn't matter if you have a bit of overhang there, it doesn't matter at all. Oh, sorry, that point there is Z. That's construction 12. So construction 13 says draw a right angle triangle when you know the hypotenuse on one side. So this one is a right angle triangle of hypotenuse 6 centimeters and side 5. So there's my 5 centimeter side. I'm going to break with my tradition and draw the short side first. And the reason for that then is that I come along with my set square next and I draw a line that is perpendicular to the line that I have, to my 5 centimeter line. So this line here is perpendicular. Oh, I really slipped there. It's perpendicular. Okay, so we have 2 perpendicular lines. There's my 90-degree angle. The next thing I do is take my compass and set it to 6 centimeters. Okay, so this is already set, is it? To 6. I stick the needle in here, and that line there, that arc, is 6 centimeters from this point here. Okay, this distance to this distance, and every point on that arc is 6. And as usual, we leave our construction lines on the paper. We want to make sure we've shown the examiner that we know what we're doing. That line there is 6 centimeters long. That one is 5 centimeters, and if you do Pythagoras, you get something horrible. So I think that's root 11, square root of 11. Okay, so that's that one. Construction 14 says draw a right-angled triangle with where you're given one side and the angle on it. So I'm going to go with a 5 centimeter side and a 45-degree angle. And the reason for that is any 90-degree angle, any right-angled triangle with 45 degrees in it, well, that's an isosceles triangle. The other angle that's left has to be 45. So again, with your set square, draw a perpendicular line through one end. This is my 5 centimeter line here. Draw a perpendicular line through one end of it. And then all you have to do is take your compass. I could use my set square here, your protractor. I could use my set square here, but because you need to be able to do this for any angle, I'm going to use my protractor, which we use for anything other than 30, 60, or 45. There's 40, there's 50, there's 45. There's that point there. And I connect the two. This point and this point. Now, if I've done this right, I should have a 45-degree angle here, a 90-degree angle here. So that should be 45. And I should have an isosceles triangle. So that base was 5 centimeters. The distance from here to here should also be 5 centimeters, which it is. Okay, so that's an isosceles triangle, equal sides, equal base angles. Construction 15 says draw a rectangle given the two sides, the lengths of the two sides. This is actually a little bit trickier than you might think. Not much trickier, but a little bit trickier than you might think. So we start off by just drawing a big long line there at the base, and we draw a line perpendicular to that line. Okay, so let's do it over here. There we go. Okay, these two lines are perpendicular. They should line up with the set square. And let's carry that on through. Okay, so if you're doing this accurately, you're not actually measuring it out with a ruler. Not the whole thing anyway. So we've got our 90-degree angle. You know, a rectangle is a shape that has 4 90-degree angles and 2 pairs of equal sides. So we want 6 centimeters and 8 centimeters. So let's see, our compass is at 6 there. So we mark off 6 centimeters from here. We actually need to go a little bit higher. And right up on top of the writing there. There's our 6 centimeter line. There's the top of it. And our 8 centimeter line. Again, mark that off. Okay, so there's our 8 centimeter line. And now what we do is we take our two set squares, or ruler and a set square, whatever you want to work with, and we draw parallel lines. Okay, so that's the whole thing with a rectangle and a square, opposite sides are parallel. Okay, so that line needs to be parallel. Put it through there. Okay, and I'll just complete that. And there, it's a parallel line. And we also draw a parallel line from the base of our rectangle. That's a bit awkward. And yeah, we can still get away with that. Okay, through there. codes at the top of my paper are making it a bit awkward, but anyway. There's our other parallel line. And if you want to check it, well, let's finish that off first. There we go. If I've done it right, geez, I hope I have. All four sides should be 90, 90, and 90. Okay, 4 90-degree angles make a rectangle. There's all the constructions, 1 to 15. Hope you enjoyed them. I hope you do well in your junior cert. Best of luck.